Hello, this is another trigonometry video, and in this video we're going to be looking at problems in context. So we're going to be using all of our SOHCAHTOA stuff that we've learned across the last couple of videos to solve sort of wordy problems which involve right-angled triangles. So let's have a look. First of all, reminder of our SOHCAHTOA triangles. So if we have a problem that involves an opposite and a hypotenuse, we're going to be using sine. If we've got a problem that involves an adjacent and a hypotenuse, we're going to be using cosine. If we've got a problem that involves an opposite and an adjacent, we're going to be using tangent. So if you don't have these written down somewhere, it might be a good idea to do that just now. Let's look at this first question. So it says, Ian measures the angle of elevation to the top of this tree. So angle of elevation just means sort of from looking at the ground to from the ground to looking at the top of the tree. What is that angle? And he measured it to be 33 degrees. He also measures his distance from the base. So from the base of the tree, he was 9.5 meters away. And from that information, we can work out how tall that tree is, because we've got here a right-angled triangle, haven't we? There's the distance that we want, that's the height. So let's think like we always do when we've got a trigonometry problem. Let's think about labelling those sides. So here's the angle that I'm talking about. So this side here must be the opposite. I'm going to choose a colour that we're going to have to see through the leaves. Opposite, there we go. And this side here, well, it's not the hypotenuse, is it? Because that's the hypotenuse. It's next to the angle, so that must be the adjacent. So this is the adjacent. Good. So I know the adjacent. I want to find the opposite. Which of these is going to help me then? It's going to be a tangent problem, isn't it? We're using tan for this one. So like we've done before, we're going to cover up the thing we want to find. In this case, I want to find the opposite. So we cover up the O in our triangle, and then the T and the A are next to each other. Remember, when they're next to each other, that's telling me that I should multiply them. So T, what does the T stand for? The T stands for tangent of the angle. So I'm going to, let's use this space up here. Tangent of the angle, that's tan 33 in this case. And then I'm going to multiply that by, what does the A stand for? It stands for the adjacent. So that's 9.5. 9.5. I'm going to put that in my calculator then. So we've got tan 33 multiplied by 9.5. I've got 6.169 and a bunch of other stuff after that. The question has asked us to round to one decimal place, so let's do that. 6.1, the next digit is a 6, so that's telling me to round the 1 up the way. So I've got 6.2, must be the height of this tree. So we've got a 6.2 metre high tree. I'm going to pop in brackets that I've rounded that to one decimal place. Okay, so there's my answer. 6.2 metres is the height of this tree. Okay, we'll look at another. Okay, Jem's ladder is 5 metres long. She positions the base 80 centimetres away from the wall. What is the size of the angle between the top of the wall and the ladder? So let's think about this picture here. What do we know? We know the ladder is 5 metres long, so that is this bit here, isn't it? That's all that length up there. That's a very wobbly line now. I'm going to try that one more time. That's better. So we know that that length there is 5 meters. What else do we know? The base is 80 centimeters away from the wall, so that distance there is going to be 80 centimeters. Now, because of the perspective of this picture, it's a little bit tricky to work out like what my sides are, where my angles are, things like that. So I'm going to redraw this picture, imagining that we're sort of looking from this side. So we're looking sort of straight on from this side. What are we going to see? Well, we'll see the floor, like that. We'll see the ladder, and we'll see the wall. And we know angle between the wall and the floor, that's going to be 90 degrees. We know the length of the ladder is 5 meters, and we know the distance from the base of the ladder to the wall is 80 centimetres. I'm going to change that so it's in the same units as this one. So instead of instead of 80 centimetres, I'm going to write 0.8 metres. Okay. And which angle are we trying to find then? Between the top of the wall and the ladder. So this angle up here is the one I'm after. Okay. So for this question, we sort of had to draw out an extra diagram because this diagram it doesn't have a right angle triangle in it for us to use. So we had to work out where that right angle triangle is, and we had to draw it for ourselves. Next step, like we always do in a trigonometry question, is we label the sides. So this 5 metres, that's the hypotenuse, isn't it? It's definitely the longest side, and it's also opposite my right angle, so there's the hypotenuse. How about this one? Well, it's opposite the angle I'm trying to find, so it is the opposite. Okay, good. Right, if I've got a hypotenuse and I've got an opposite, which of these is going to help me? This one this time, isn't it? It's a sine question. And I know the hypotenuse, I know the opposite, so the thing I'm trying to find is, well, initially sine of the angle. So if we cover up the thing we're trying to find, cover up S for sine of the angle, and let's write what I'm going to stick in my calculator. So sine of, let's say A for the angle, is equal to, covering up that, O over H. So that's O divided by H, right? So that's the opposite, 0.8 divided by 5. So sine of the angle is 0.8 over 5. I want to get the angle out of this sine, don't I? So that means the angle itself is going to be the inverse sine of 0.8 over 5. Okay, I'm going to stick that bit in my calculator then. I'm going to type inverse sine of 0.8 over 5. And my calculator has told me 9.206 and a bunch of other stuff. So that must mean that the angle is, we're going to one decimal place, yep we are, the angle is 9.2 degrees, correct to one decimal place. Okay, good. We'll look at another. Right, the diagram shows a wheelchair ramp. Safety regulations require that the angle with the ground is less than 20 degrees. Does the ramp meet the requirements? Okay, so first of all, let's work out which angle we're after. The angle with the ground, so that's got to be this one here, hasn't it? So that's the angle I'm after. We'll label that X for the one I'm trying to find. Let's think about what sides we've got here then. Well, this one is next to my angle. That's got to be the adjacent, ADJ for adjacent. This one, that looks like it might be the longest one to me. It's also opposite the right angle, so yeah, that's got to be the hypotenuse. So we've got a hypotenuse and we've got an adjacent, which is useful then. It's going to be a cosine one this time, isn't it? So we cover up the thing we're trying to find, in this case C for cosine of the angle. And that tells us that cosine of the angle, so cosine X we're calling it, is equal to, what does it tell us? A over H, the adjacent over the hypotenuse. So that's 10.8 over 12. So cosine of X is 10.8 over 12, which means to get X out of that cosine, we need to do the opposite of cosine. That's called inverse cosine. So we do the inverse cosine to this 10.8 over 12. 10.8 over 12. Inverse cosine of 10.8 over 12 is what I'm going to type in my calculator. 10.8 over 12. And I have got 25.841 and a bunch of other stuff. So that means this angle is, well, nearly 26 degrees, right? It's 25.8 degrees if we're going to one decimal place. But we don't stop here. We've not answered the question, because the question was actually not what's the size of this angle. The question was, does the ramp meet the requirements? Now, what do the requirements say? Safety regulations require that the angle with the ground is less than 20 degrees. I've just found that the angle is nearly 26 degrees, so it's much too big. This ramp is too steep to be safe. So, does the ramp meet the requirements? No. The angle is too large. Okay, good. We're going to do one more example then. Okay, the diagram shows a square and a right-angled triangle. And we should mark on where that right angle is. It's this bit up here, right? There's my right angle. And we're asked to calculate the area of the square. So if I'm going to calculate the area of a square, that's length times breadth, isn't it? But because it's a square, those two are going to be the same. The length and the breadth will be the same number. So if I can work out what one of those numbers is, this one say, then I'll be able to work out the whole area of the square. So that means I need to work out what is this length here. That's the one I'm going to need to find. And I reckon I can find that because I've got this right-angled triangle, and I know this side, I want to find this side, and I know this angle in between them. So first thing is, like always, we're going to label the sides of this triangle. So this one here is the hypotenuse, isn't it? That's the hypotenuse of the right-angled triangle. It's the longest. It's also opposite the right angle. What about this one then? Well, here's the angle that I'm going to be using. It's next to that angle. So that's going to be the adjacent. So which of my functions am I using? Is it sine, cosine, or tangent? I'm using cosine this time, aren't I? Because I've got an adjacent and a hypotenuse involved. Cover up the thing we want to find. We want to find the h. We want to find the hypotenuse. So we cover that up. And it tells me it's going to be a over c, a divided by c. So the hypotenuse is going to be equal to, the hypotenuse is equal to the adjacent divided by cosine of the angle. I'm going to say a for angle there. Let's put some numbers in. What is the adjacent? Well, it's 7. What's cosine of the angle? Well, that's going to be cosine of 58. 58. So I'm going to pop that in my calculator. 7 over cosine of 58. You could type it into your calculator like this. 7 divided by cosine of 58. They mean exactly the same thing. So that's what I'm going to do. 7 divided by cosine 58. I've got 13.209 and a bunch of other stuff. I'm not going to round this number just yet. So the length of this side is 13 and a bit centimetres. Are we in centimetres? Yeah, 13 and a bit centimetres, which means this side must also be 13 and a bit centimetres. So what I'm going to do is, to work out the area, I'm going to multiply this 13.209 by itself. I'm going to square it. If I square this, that's multiplying it by itself, right? And that will tell me the area of this square. So in my calculator, I'm not going to do any rounding. I'm not going to retype this number. I'm just going to do ants. So I'm going to press the ants key on my calculator. If you've got a Casio calculator, the ants key should be just next to your equals button. If you've got a Sharp calculator, you might have to press the green alpha button first to get that ants. But either way, if we do ants squared, then we haven't rounded our answer yet, and it means that the final answer we get will be a little bit more accurate. So that's what I'm going to type. I'm typing ants squared into my calculator. I'm pressing equals, and it is telling me that the answer is 174.4924 and a bunch of other stuff. So, sort of running out of space here, aren't I? I'm going to choose a different colour and write my answer somewhere else. So, the area is the answer squared because it's length times breadth, so it's 13.2 times 13.2. We get this number here. Now we can round it. Now we get to our final answer. We can round it to one decimal place. So the area of that square is equal to 174 point... I've got a 4 followed by a 9. The 9 tells me I should be rounding this guy up. So it's 174.5, and we should get some units on the end of that. I've run out of space a little bit, I'm going to write them underneath. Centimetres squared. That's how we measure area, isn't it? Centimetres squared. Cool, so the area of this square is 174.5 centimetres squared. There we go. Okay, I'll see you later. Cheers, bye.